Just in physics, the use of Greek alphabets is ubiquitous, but most students are quite unaware and oblivious to Greek symbolics. And I, in my class, always make sure that before communicating post-16 physics lectures, I do go over Greek alphabets and symbology and the uppercase and the lowercase Greek alphabets prior to starting the physics curriculum, be it BTEC, HNC, HND or post-16 A-levels. So the first alphabet is, and some say that, English alphabet is a derivative of Greek symbols, which I can't disagree. And so this is alpha. That's the uppercase, that's the lowercase, and it's alpha. The second one would be beta. These are the Greek versions, and beta. And then you've got gamma. Gamma is curved. Now in the computer software MATLAB, it won't come out curved, but in reality, in calligraphy, it's curved. So the penmanship needs to be modified. And then the capital of beta would be B. The capital of gamma would be just this. That's about it. And some people put a kink here, but you can put a kink or and make it like that. So that's unusual enough. So that'll be gamma. Uppercase, lowercase, uppercase, lowercase, uppercase, lowercase. Followed by delta. So A, B, C, D. So that's a small case. And the larger one is D. This you may be aware of because this triangle is used quite a lot in kinematics and chemistry equations. It's used in bonding chapter of A-level chemistry and kinematics and dynamics of physics. And then you've got epsilon, which is E. Sorry, I'm working from memory, so I'm a bit slow. I apologize. And then you've got Zeta. It's quite, when I was young, it used to confuse me quite a lot because Zeta, I was like, why did Z come after E? But then again, you have to remember it's the Greek language, not the English language, so that's Zeta. It's used in the capillary electrophoresis. It's the isoelectric constant, and that's used in capillary electrophoresis. So followed by eta, I think. Zeta, eta. And that's this symbol used in Stokes' law. And I think if I remember correctly, capital is H. So it doesn't make any sense, but just go along with it. And then you've got theta. So zeta, eta, theta. And the capital and the the uppercase, small case version is quite similar. So small case, uppercase. And then you've got iota, which is basically I. Ta. So zeta, eta, theta, theta, and iota, followed by I think it's kappa or lambda. I think I think it's lambda first. No, I think it's kappa. Sorry, kappa, and kappa is just K. So basically phoneme sounds, phonetic sounds, and then you've got lambda. I think lambda. Lambda is a bit like this, and then there's a little circle on top. It's not angstrom. Angstrom's different, so bear with me. Angstrom is alright, so that's that. Now so how many? There are about 24, 26, 24 in the Greek language. So we've done about 3, 6, 9, and 11. So that's lambda. We all know where lambda is used. It's used in photon chapter, particle physics, but it's this version used a lot more than this one. And kappa is used in particle physics as well. Iota is not used very much. It's used in pure mathematics, and theta is obviously, we know, in trigonometry. Sine, cosine, theta, secant, cosecant, and cotangent. And then we have mu. Now mu is that's used in micro to demonstrate 1/1,000,000th of a particle. So, and then we've got nu. That's used in particle physics. E equals hf. E equals h nu sometimes as well. And that's n. And then we've got the symbol, which is quite similar to I don't know, I forgot what it's called. It's a xi something, yeah, xi, z, and then it's these are just 3 lines. It's depicted as 3 lines, and then you've got Omicron. That's just O basically. So this is mu, not micro. Micro, it's used as a symbol for 1/1,000,000th, but that doesn't mean it's micro. It's always used in terms of micro, but it's not. Sometimes it's used for permittivity constant as well. So you can't really say it's always used for micro. When it has a certain place in electricity, electric field theoretics, and general dimensional analysis. And then we've got pi. You know, we all know what pi is. 22/7. That's pi. That's just a symbol. The fact that it's being used to represent the ratio between circumference and radius, that's a completely different issue. And it's capital is very, very similar. Looks like 2 bars down with 1 on top. And then you've got rho. That's used for density. I think if I'm not wrong, the capital is it looks like a P. And then you've got sigma. Oh my goodness, we all know where that's used in statistics. And then I think there is upsilon. So there's epsilon, and then there's upsilon. That's just a simple U, but its capital version, uppercase version, is a Y. And then you've got phi. I remember phi. And then you've got chi, I think. Call it chi. And then you've got psi, which is used in it's used in probability, quantum chromodynamics, as well as quantum mechanics, basic quantum mechanics. And that's about it, I think. And there's one. Oh yeah, I think I'm forgetting one. It's omega. So radial velocity. And the capital version is used for resistance ohms. So small version, large version, small version, large version. Now we will summate it. I'm going to summate it now. So Greek symbols. We've got Greek symbols, and the first one is alpha, then followed by beta, gamma, delta, epsilon, zeta, eta, theta or theta, beta or beta, beta or theta, and theta or theta, iota, kappa, lambda, lambda, there's lambda, right, mu, nu, xi, omicron, pi, rho, sigma, upsilon, phi, chi, and then psi, and then omega. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 17, 21, 24. So yeah, I was correct. So it's 24 as I remembered. 24. I'm glad I was able to remember all of them. 24. There's 24 of them. So again, last time, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, z, omicron, pi, rho, sigma, upsilon, phi, chi, psi, and omega. And I've just described the use. This is used in radioactivity. A little bit. Sometimes they're used in Euclidean geometry. Euclidean geometry as well, and then you've got gamma in radiation physics, delta in chemical bonding, in dipole interactions, and then epsilon's used in Beer-Lambert's laws equation, then zeta in electrophoretic constant in capillary electrophoresis. This is used in the Stokes law of fluid dynamics. This is used in trigonometry and locus, and this is used in pure maths, I equals -1, under root -1, and then that's used in particle physics, electrodynamics, electrostatics, particle physics, electrophoretic constant, I think, yeah, that one. And then, I don't know, this is maths, this is density, used in fluid dynamics, hydrostatics, hydrodynamics, mechanics, and then the sigma statistics. Nope, I don't know. Phi is used in advanced pure maths, I don't know. And this one is used in quantum mechanics, and this one's used in physics and maths, and M1, M2, M3 as well. M1, M2, M3 in now these things, this alphabet needs to be reinforced because this gives you a clear understanding of what each component is, and what each alphabet stands for, and how it's used to describe different quantities in physics. And yeah, it's the Greek language that's used in science. So the nomenclature is Roman and the symbology is Greek. Thank you very much. Take care. Bye now.